Welcome back to Groundhog Graphics. I'm doing another live stream tonight after work, so it's been a hot, hard, difficult day, so I don't know how great I'm going to do at this, but I'm still going to do a little bit. So what I'm working on tonight is basically a copy of the sprite editor for the Commodore 128. Because it's just very simple. I'm not really going to use it for making sprites, but I kind of want to use it to draw schematic symbols with. So I'm kind of just patterning it after the C128 sprite editor. And what I've got so far is not much, but I will show you. It is draw sim for draw symbol, and it draws a box, and that's what I have so far. And after thinking about it, I realized that I'll have to change this program a bit anyway, because I need to be able to change the individual background colors of each cell, and in order to do that I need to use extended color mode. And to do extended color mode, you're limited to the first 64 characters of the character set. And I'm using a reverse space to draw the box, and that character I don't think will exist. But that's okay. I can do the same effect by just changing the background colors of those squares in the extended color mode. But anyway, that's where I'm at so far. So I'll show you the program. Draw sim.c. And this sets up a table of rows for the memory addresses, starting with the screen memory at 400 hex. And then it goes for each and every, all the 25 rows, and it will just basically create a table, a reference table for each starting memory address along the left side of the screen. So this would be 400, and then this would be, well, this would be 400 plus 40 decimal, and then plus 80 and so forth. So it will set up this table for a reference. And the reason why I did this is just in case, I don't know, maybe I want to change this over to a machine language at some point. I don't think I'm going to, but I would probably use that in a machine language program. In this, it's not really necessary. I could have just done multiplication, and I could have just made a formula to adjust for it. But anyway, that's what I have so far. So it makes a table. This draws a box. That draws the box that you saw on the screen. Has a beginning X1, Y1, X2, Y2, and then C for color. I haven't implemented color yet. And it draws the box. I believe this draws the horizontal top and bottom lines, and this one will draw the vertical lines on both sides. And then the main function sets up those rows for the screen, and it draws a box. That's what I've got. That's it so far. So now that I've realized I'm going to need extended color mode, I've implemented that before. I forget how to do it. It's not difficult. But I'm going to load up I'm going to mount another disk of mine and take a quick peek at that so I can see how I did that before. So I'm going to mount it on drive 10, and I'm going to go to Power C, lib, and I'm going to do this one here. And then I'm going to get out of this, and we're going to make 10 our work disk. Get a directory on it and try to see which file do I need to look at. I believe it would be the G graphics 1.asm maybe. ed G graphics. There's 2 as well. 2.asm. Let's see what that is. Usually the higher the number, the later the version. Usually. I do that just in case I'm trying something new and I don't want to screw up my old code, just in case my new idea doesn't work out. So I end up getting all these little numbers on these names, and then I end up later on going, oh, well, what's this one and what's that one? So it becomes confusion as well. Let's see here. It's a pretty big file. You know what? I don't think it'll load the whole file. I think this file is too big. No, it is. It's loaded it. So, okay, good. So what I need to do is I need to find the graphics command. I think it is that, right? No. The graphic command. F3. And there it is. Let's see here. Set multicolor mode, text mode, multicolor mode, high res mode, clear the bitmap. Yeah, I don't think this has the extended color mode implemented in it yet, so this is a wrong version. Clear, get graphics 1.asm. Let's see what that one's got in it. Key press / graphic. Okay, / graphics. And that's no good. Alright, clear that. Get graphics.asm. And watch, this file won't be too big. Hopefully not. But even if it is and it doesn't load at all, maybe it'll at least get the part I'm looking for. Setting the extended color mode is very simple. It's just changing one bit in one register. I just don't remember what exactly it is. I could probably look in the Commodore Programmer's Reference Guide and find it too. But I thought maybe this would be easier. Obviously not. Out of memory. Okay. Let's look for graphic. F3. F3. GR mode. Maybe. That would set up the mode for the graphics. Let's see here. Yeah. GM5. Graphic mode 5, that's what I set it up as. Graphic mode 5. So it is the VIC register 17, and we turn on, or it was 64, which is what bit is that? So 1, 2, 4, 8, 16, 32, 64. So that would be bit 6, I think. So if you turn on bit 6 of the VIC register 17, that's great and all. But what memory address does that translate to? If I could find that in here, MVIC 17. I would also have a VIC 17 in here as well, I think. VIC 17. Going to the top of the page. Okay, VIC2 is at D1000. CG mode. Okay. Go back to GR mode. And F3 again. And there we go. And I think down below we actually enable graphics with this command. So it is still elusive. Okay. VIC2 plus 17. Alright, whatever. Calculator. What was it? D1000? Where's D on here? Wait, hex? Hex. Yeah. D plus decimal 17, I think it is. And we go back. And that didn't work. D000 plus 17 equals, go back, that's D011. Jeez, that was extra complicated. Okay. D011 bit 6. So now, clear this, no, quit this. Work 80, CD, draw, sim, dot, C, define, D011, and we will put this as VIC 17. There we go. And then to turn on extended color mode, we will do I could do that too. M. This is a holdover from the language Promel. If you've ever programmed in that, to access specific bytes in memory, it has an array called M. And I don't know, I don't need it right now, but I'm going to go ahead and use M, just like it did in Promel. But we're going to do VIC 17 equals M VIC 17 ORed. It was 64, and that should turn on our extended color mode. And F2, and I will define M. M could be just anywhere in memory. So character M, there it is. That should work, right? It should work. I think so. If it doesn't, we'll fix it. It should work. And then we could do M VIC 17 or 64. Draw a box. Now when I draw the box, I'll be drawing it with a character that doesn't exist. So that'll be interesting to see what that does. Let's go ahead and save it. Put draw sim.c. quit. CC draw sim.c warp mode. Link it. Draw sim.o. Delete key for my vice map is the up arrow, and my vice map is available on GitHub. There we go, and we will overwrite the old one. Draw sim.sh. Get. Ah, yeah, there we go. Yep, I believe that is, I believe that's the extended color mode. So it's all red, that's okay, but it seems to work. So I'm guessing, now I can't remember, I think that the screen memory must also contain the color of the background. Let's go ahead and look at the programmer's reference guide at this point. Let's see if we can search for this extended color mode. See if we'll find that. Extended background color mode. Gives you control over the background color of each individual character, as well as the foreground color. There are 4 registers available for extended background color mode. Color memory is used to hold the foreground color. Okay. When extended color mode is on, search for 64 characters and character ROM, right, which we knew. This is because the 2 bits of the character code are used to select the background color. Okay. So the character code that you would poke to the screen of letter A is a 1 when extended color mode is on. If you poked a 1 to the screen, an A would appear. If you poke 65 to the screen normally, you would expect the character with character code 129 to appear, which is a reversed A. This does not happen in extended color mode. Instead, you get the same unreversed A as before, but on a different background color. The following chart gives the codes. Background color register. Number. Okay. So we only can have 4 different colors for our background on the screen at one time. Yeah, it's kind of limiting. Okay. Okay. So these are my registers, huh? D021 through D024. Copy that while I've got it. That way I'm not searching for it later. CD draw sim.c. So it's still in extended color mode, Okay. Alright, let's quit this and do a run stop restore. There. CED draw sim.c. Okay. Excuse me. Now we will define color 0 as D021, which that was right, yep, and that should be all we need. We can pretty much figure out all the other ones. So color 0, okay. So if I want to do color 1, okay. So currently we're putting 128 plus 32 on there. Reverse space. So that sets us, so what does that put us at color 2? I think so. 128 plus 32. And look at binary. Yep, that puts us at color 2. So if we change color 2, we should get a different color. Alright, let's try that. Color 0. Draw a box. Okay. So M color 0 plus 2, right, equals, I don't know, 12. Color 0 plus 2. So it'd be 0, 1, and 2, so it should be right. I don't know what color 12 is, but I can find out. Go 1, get C64.h. And go down here and see my little color array. TX yellow. So this is 0, 1, 2, 3, 4, 5, 6, 7. Let's do 7. And let's save this. Draw sim.c. Quit. Compile this and see if, I wonder if it changes the color instantly after we've already drawn it. That's also what I was also curious about. Should, like changing a palette color. And draw sim.o. And it does. It works. Look at that. So now we have a yellow border. So what I'm thinking of doing is I'd like to draw schematic symbols for electronics. So I was thinking a good size would be a 16 by 16 bit or dot schematic symbol. So this represents, should be 16. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So inside here would be where we would draw whatever schematic symbol we want. It would be better, of course, if it was a single character, an 8 by 8, but I don't think I can fit every schematic symbol into an 8 by 8. I think that would be a little bit too much of a restriction. So that's why I figured 16 by 16 should be workable. And it's still reasonable for the size on the screen. I mean, a 16 by 16, look at this. There's your 16 by 16 area. So I think that's a reasonable size. You can have a whole lot of components on the screen. If you went with that size, it would still be fine. So, okay, we've got extended color mode. CD draw sim.c. So rather than make this color 2, let's make it color 1. Color 1. So we will do 64 plus 32. And that should give us color 1. And then, of course, I forgot to do the run, stop, restore. Change this to that. Save this. Put draw sim.c. Quit this. Run, stop, restore. CED back into it. Draw sim.c. And at the end of the program, so we don't have to keep doing this run, stop, restore, let's go ahead and get rid of extended color mode. Turn that off. So M Vic 17 equals M Vic 17, and we will just do exclusive OR 64. Which we could even make this define this. We could do that too as a extended color mode toggle. Define tog extended color mode XCM, and we could do, instead of using M, we could do character pointer for D011, and we could equals character pointer so times D011 and exclusive word with 64, and that would give us a toggle, assuming I wrote that right, and make it look like a function. We could do that too, and let's see if that works. Tog XCM. Okay. Put put this draw sim.c. And we'll do a syntax check. And I realized that I did something I didn't need to do. We should just be able to do exclusive or equals 64. I think that should work. Let's check it again. Put this and compile it and see if it compiles. Draw sim.c. Let's see if this works. I think I'm getting rusty with my C because I've been programming machine language and I haven't been programming in C enough lately. Of course, this will instantly turn it off. Didn't think of that, but whatever. It's compiling, so I'm going to say at least the define that we made works. It's not causing an error. Let's go ahead and go edit the program again. It's warp speed, cd, draw sim.c. And this is normally shift run stop. On the Vice key map that I have, it is shift escape, and it will put us into like block copy or delete mode, basically cut or copy. So I go down arrow and you see it selected that, and then I would hit F5, right? F5. Oh, there. I turned off my function keys. Hold on here. What do I do now with that? Shift escape, I think, fixes that. And okay. I don't need that. Oh. Okay. Now let me cut this out. 5. Dang this thing. It's a shortcut key in Windows, or in Windows. If you hit Shift Escape, it makes your function keys turn into media keys, which I don't want, but this is what it's doing to me. So now I'm having to hit the function and F5. I'll have to figure out how to fix that later, because that's annoying. I never use media keys, ever. I just want function keys, but it always wants to turn on media keys. Always wants media keys. I don't use those, ever. Okay. Now, let's put in get character, right? I think so. Let's put character, should be get character, and save it. Put draw sim.c. At least this will give us a chance to look at it before it reverts back to regular text mode. Exit here, quit, CC. Oh, you know what I should have done? was get CH. Let me look at the Power C manual real quick. I told you I'm getting rusty. Because this would not even have been a question for me before. Control F, get CH AR. Okay. Yeah, it does have it. Okay. I don't know why I'm questioning everything, but I don't know. For some reason, I don't remember using get CHAR very much, but I probably do. Anyway, that's there, that's saved, and we can compile. Draw sim.c. Link. Draw sim.o. Draw sim.sh. And that's why I don't use get character that often, because it puts the blinking cursor on there. That's why I usually use get ch. Okay. So, well, whatever, it works. cd draw sim.c. Okay. So, now what we need is a cursor to go in that box. On the Commodore 128, I think it's a plus symbol, and we'll just go ahead and use the same thing. And we need to put a plus symbol in there. But what is the screen code for the plus sign? Let's take a look at the Programmer's Reference Guide. Screen codes. Plus sign 43. Okay. Hmm. There we go. And we need to make this cursor that moves in the box with the plus sign. Oh, you know what? I wonder, I forget now, with the Commodore 128, when you're using the sprite editor, if you change the color of the sprite, I wonder if it changes the box that they use as the border for the sprite editor itself. I don't remember if it does, but I'm pretty sure they're using extended color mode as well. And I was thinking, because if I wanted to change sprite colors, then eventually I would end up changing the color of the box too. Because I only have 4 colors to choose from. Well, whatever. I don't need to worry about that right now. It's not a big deal. You can change the color of the border. It's fine. but I need to put the plus sign there. So it needs to work on a grid. It needs to be restricted. I need to set the constants for the boundaries of the box. So put that here. Define. Box X at 16 and define box Y as 16, and then draw a box. We could put draw border 1, 2, 3, 4, 5, 6, 7, 8. Draw border, and we could just put empty, and we could do this. Copy, cut this out. F5. F6, F6, and make this box X plus 1 and box Y plus 1, and call this draw border. Now the reason why I made this separate right now, I'm drawing a border, and I'm also drawing the box, and I'm using draw border to draw the box, is because draw border is going to use the define from above, so that if I wanted to make this a sprite editor, which obviously it'd be pretty well suited for that, I could just simply change box X and box Y, and then this program would automatically change the border size appropriately, properly. But I don't want to change it in draw a box, because draw a box means draw a box. I want it to be accurate. So draw a box needs to draw whatever you give it. Draw a border, or if I rename it later, needs to draw the actual boundary for the sprite editor, or in this case the symbol editor. So that's why I've separated it. So draw border. Okay. And then we got that, and we need to draw a plus sign in it. So we need a way to draw characters on the screen. Draw a cursor, maybe. Draw cursor. And we could put X, Y, and sign X, Y. And we will put static, because I wanted to keep the old X and Y. Old X, comma, old X equals 0, no, 1. static unsigned old y equals 1. And then we will put we'll use our little table for our rows. So it'd be SRY, SRY, or old y, equals 32. Plus old x. And we will copy this. And Shift F6. And then we will put the cursor in the new place. Equals plus and then we will old x equals x, old y equals y, and then we'll return. Draw cursor 1, and we'll see if we get a plus sign on our grid. Let's see, put draw symbol dot C. Symbol.c. Work mode it. Link it. Draw symbol.o. And there's our plus sign. Very good. Enter, turns it off. And so we're making a little bit of progress. CED, draw symbol.c. So now we need to do a loop while keyboard input KI not equal E for end. And then KI equal get CH, because I don't want a flashing cursor. And then we will do switch KI case, key up, break, case key down, break, key right, break, case key left, break, default, break. And where are we going to get our key up, key down? From my header file, C64.h. Go 1. But rather than include it, I think I'm just going to copy it. Just get all these. Function F5. Go main. F2. Top. And we will go ahead and F6. So paste this. Now we have our key up, down, left, and right. And then we need to know what the X and Y is of the current cursor. So we need to make that global. Let's see, character or unsigned. Curse X, curse Y. Curse X equals 1. Curse Y equals 1 for our starting place, starting position. Then we will curse Y minus minus. So Y plus plus. Curse X plus plus. Curse X minus minus. And then we will, just for now, without any kind of safety, we will just draw the cursor. So really, we could put that right here. Draw curse, curse X, comma, curse Y. And we can get rid of this. 5. And now we should have a cursor we can move around. Let's save it. simple.c. Check for any syntax errors. Everything looks good. Compile it. Draw sim.c. Oh, didn't declare the KI. Okay. D draw sim.c, and we will make that. We'll get the KI declared. And we will have it equal, I don't know, space. Okay. Put that back to disk. Draw sim.c. And there we go. Get compiled. Link it. Draw sim.o. Get ch.o. Probably not on there. Not found. Alright. Copy. Well, work 90. Let's see if it's even on there. Dir. Well, we could do L. L get ch.o. It is. Copy. Source drive is 9. Destination 8. Get ch.o. Work 8 again. Link. Draw sim.o. ch.o. Draw sim.sh. Draw sim. Let's see what we got. Plus sign. And it works. It eats everything that goes over. So we want to stop that. But it works. There it is. We got a cursor. And then this is where we put our little dots in and draw a schematic. And then I'll use a sprite on the right side of the screen to represent the schematic we're drawing so we can see it in actual size. And then we'll create a function to save it. And then I have a way to draw schematic symbols. So let's hit E and we end. Perfect. Let's see. Draw sig.c. So what we will do is preserve the high 2 bits. Equals 32. ORed with the current value that's in there, so it doesn't disrupt the color. SR old Y. No, but that won't work either, because that would also make it where it will disrupt the character. That won't work. That won't work. No, it will not. I don't want to create a really super long statement here either. So we have to AND it. So it'll be AND equal. What is, let's see, 128 plus 64. 128 plus 64. 192. Yep. But really, we don't have to put it like that either. So we will put AND equal, and this is why I say I'm getting rusty. How would I write a binary number in C? Jeez. Let's look that up real quick. Definitely rusty in C. 0B? What? Maybe there is no good way to do it. I don't remember. I've been using an assembler where I can do this, but then I'm thinking I could do it in C, but I guess not. That's okay. It's not a big deal. Alright. So AND equal. So Was that 8? 1, 2, 4, 8, 8, 9, 10, 11, 12. C and C 0, and then we will do this. We should just copy it. Let's see. F5, F5, 6, and we will do or equal 32. And then the plus can always be or equal, right? I don't know. Depends on what the plus is. It's let's see what plus is. The character screen code for that is 43. Let's see, 43 101011. Okay. 1, 2, 4, 8, 1632. So yeah, if I OR it, it should be fine because 32 is space and that bit's already set anyway, so I shouldn't need to clear anything. Let's go back here, and we can just OR equal with the plus and keep the same color underneath the plus sign. And I think this should work. Clear it, or equal 32. We set the plus sign. Okay. So now hopefully we have a way to preserve what is underneath the plus sign, and when it leaves the color undisturbed. So let's try that. Put draw symbol dot C. Quit draw symbol dot C. Link it. What? What are you saying? Okay, thank you. Draw sim.o. Get ch.o. Draw symbol .sh. Let's see, it preserves the background. The background color, that is. Yep. That works. Background color is now untouched. Well, that's probably about all the progress I'm going to make tonight, because I have to get up for work tomorrow and get to bed. But at least I got a little bit of a Programming Live done, and that's cool. And hopefully we can get some more going on here soon, hopefully. So until then, hit E, we're done. Thank you for watching, and I will see you in the next live. Bye.